Looking at part C, it's a bit backwards from what we've been doing. Okay, so in the previous questions, we always start from the inner one and we plug a 4 into F, right? And then we got a 2, and then we plug that 2 into G. So when we think about the order in which things are happening here, we always think about the inner function first, and then we think about the outer function. So the inner function here is G, and then the outer function here is F. Okay. What's different about this question is that they don't give us the number, they give us the answer, right? So they're saying at the end of the day, we're going to get a 3. Okay, so we're going to take some number and we're calling it x, and we're plugging it into the inner function first. Something comes out, so we get some number here. That number gets plugged into f and comes out as 3. So what we want to do is we want to go kind of backwards, against the arrows. So we're going to say, what number do we plug into f to get a 3? In other words, f of what number gives us 3? I would put an x here, but we're using an x over here as well. So when the y value is equal to 3, what's the x value going to be? Okay, so let's go take a look at, we're looking at function f. We're looking at function f, and if the y value is 3, it looks like there's two possibilities here. It's a little bit different here. So here, oh, I'm sorry, you got to steal that laptop card. Here we can say f of 0 is equal to 3. Here, f of -4 is equal to 3. So in fact, this question's a little bit complicated in a way because we got two answers, don't we? So when we're asking ourselves what could have produced that number here, if y is equal to 3, x is equal to, we had two answers, didn't we? We had -4, -4, or 0. There's two of them. So let's keep track of both of them here. We've got -4, comma, 0 here. Now we're going to say, we'll have to do this separately. We're going to say, what did we have to plug into G to get a -4? Or what did we have to plug into G to get a 0? So in other words, G of what gives us a -4, and a G of what gives us a 0. So in other words, what's the x when y is -4? What's the x when y is equal to 0? So looking at our function g, what is x when the y is equal to -4? We don't have an answer, do we? It doesn't go to -4. So there is none here. No answer here. There is no x value that we can plug into g so that a -4 comes out. But how about 0? How could we get, what's the x value that we could plug in so that our y value comes out as 0? So our y value of 0, so here's one. This is -2, 0. And this is 1, 0. Or to put it into more function notation, if we plug in function g, if we plug in an x value of -2, we get a 0 coming out. Here, if we plug in an x value of, oh, this is 2, isn't it? 2, oh, there it is, sorry, 1. If we plug in a 1, then for our x value, then we get a 0. So our answer here is going to be either -2 or 1. So our answer at the final is -2 or 1 is our two answers. Let's try it out. If we plug in a -2 to g, if we plug in a -2, we get a 0. And then in f, if we plug in a 0, we get a 3. And so that's what we wanted, right? We wanted to get a value of 3. Let's try another one. If we plug in a 1 to our g function, if we plug in a 1 with our g function, we also get a 0. And if we plug in a 0 for our f function, then we get a 3. So that is our two answers. Okay, moving on to the next page. Determine f of g of x and identify the domain. So here I'm going to start off and write f of, and instead of g of x, I'll write x squared minus 4. Okay, and now this will be equal to, wherever I see an x in here, I'll substitute x squared minus 4. So it's, in other words, it's easier to visualize if I write it again like this, equals the square root of. Now wherever I see this x gets put in over here, so now I get x squared minus 4 plus 3, right? How that works. So this is going to be equal to square root of x squared minus 4 plus 3, which can be equal to the square root of x squared minus 1. You should recall we did this in class, right? So this is our answer, f of g of x equals that. So that is determined, that's the first part. Now to identify the domain, the big thing is that x squared minus 1 has to be greater than or equal to 0. Okay, and we can do this by two ways. You can factor this and say either they both have to be positive or they both have to be negative. And in any case, you end up getting 0, 1, negative 1. You find out if they're both positive. It'll look like this or like this. So in inequality, if we state it like this, x has to be greater than or equal to 1, or x has to be less than or equal to negative 1. Or just as a reminder, you can look at this x squared minus 1 and you can say, oh yeah, that looks like a parabola that goes like this. And so when you're asking when is that greater than or equal to 0, that means when's the y value greater than or equal to 0. So looking at only this part of the line, right, when is that the case? Well, that's the case from here onwards, right? So that's where you get that same kind of shape as down here. So this would be your best way to answer it. If you're going to use interval notation, you could say, oh, that's the same thing as from negative infinity to negative 1, and it includes negative 1. And with infinities, you always use the rounded bracket, and that one, the union of, that's the same thing as or, and it's a similar version now here, but we're going to use the positive infinity. So that's the interval notation. Okay, almost done. Determine g of f of x and identify the domain. So now we're just going to do the reverse order. So f of x is equal to root x plus 3. So this will be g of the square root of x plus 3. And that will be equal to, so everywhere where I see an x, I write x squared. So here it's root x plus 3. So it's going to be square root of x plus 3 all squared minus 4. So my answer will be this squared is x plus 3 minus 4. So I get x minus 1. So that's my answer to the first part. And to identify the domain, there's no situation that I'm dividing by 0 or doing a square root of a negative value. So it's going to be all real numbers. Okay. And it says here, note we must consider the domain of the original graph. So when you consider the domain of the original graph now, so you got g of f of x, we're going to question whether this is not true. So there's two domains that you're interested in. So you have to, the domain of this entire composite function, this is a good part, you can summarize it over here, has to be what's common to the domain of the inner function. So you have to look at the domain of the inner function and you have to look at the domain of the composite function. So this x is all real numbers. That is the composite function. Now, what is the domain of the inner function? of f of x. Now f of x is equal to root x plus 3. What's the domain of that? Well, x plus 3, and we'll switch to a different color here, x plus 3 has to be greater than or equal to 0, so therefore x has to be greater than or equal to negative 3. So what is the domain here at the end of the day? I have to say, well, what's common between all real numbers and x is greater than or equal to negative 3? The total answer is going to be, so the final answer is x is greater than or equal to negative 3. I'm sure this is a little bit confusing right now, but when you think of what's happening here is you've got x is going into function f, right? And then that is going into function g. Whatever comes out of there goes into function g. And then this is your answer. This is your range here. This is your answer. So what are all the possible x values that you can put in? So domain of x. So if your first function f is the square root of x plus 3, it's getting squared afterwards, isn't it? So you might think, oh, it's x minus 1, it can be all real numbers. But this is like limits. Right at this spot here, x has to be greater than or equal to negative 3. You can't get a number less than negative 3 into this function f. It won't spit you out a number to go back into g. So even though at this point in g is where it's getting squared, you're not even allowed to put something in there. So if the original x, the domain is greater than or equal to negative 3, you have to restrict your final answer to what is common here. And for the composite function, which we just figured out, which was x's all real numbers, what's common between x's all real numbers and what's between x is greater than negative 3? In other words, what's the intersection of those two? So the intersection of this one and this one, what's common to both of them is x is greater than or equal to negative 3. Okay, here is your homework on page 507 to try them out, and we've reduced some of the numbers that you need to do, so hopefully you'll have time to do them in class. Thank you. Looking. Can't seem to find it.